You've made it to astronomy night through the Eagle River Nature Center, as done on Zoom. Um, for those of you who don't know me, I'm Samantha Russell Blumenkoenig. I'm the Chief Naturalist at the Eagle River Nature Center. Tonight's program is going to be recorded, and if you give me a week, but hopefully less, I'll have it put up on our YouTube channel, and I'll have links on our website as well. So if you are so moved by what Debbie has to share, or I don't know, maybe you get distracted or you have to dip out early, there will be links. This will be accessible through our YouTube channel and through our website. A couple of updates just about the Nature Center. We remain closed to the public, but your public trails remain open and are in amazing shape. Gus, our trail crew manager, has kept them packed down. They're a little bit sticky for skiing in some parts right now, but easy for walking. You don't need snowshoes. They're not slippery yet. Everything's in great shape. It's going to be an amazing weekend to be out at the Nature Center. And we saw an owl by the large viewing deck this afternoon, so keep your eyes peeled. With that, though, I'm taking through and making sure there's nothing else big that I'm missing. It's one of those kinds of days where it's like, ooh. Anyway, with that, though, we're super fortunate to have Debbie Soltis be joining us again for astronomy night to give us an update on what's going on with Mars. We have a smaller group tonight, so as you have questions, feel free to unmute yourself and ask them as you have them. We are recording this program, so if you don't, your face, whether you have your video camera on or not, isn't going to show up. It'll just be Debbie and my faces. But if you're sensitive to your voice being recorded, please feel free to use the chat box. But again, you can come in, come out, be videoed, be not videoed, whatever, participate as we go. And I'll be monitoring the chat box, and if anybody has any questions or is having any tech problems, feel free to direct message me and we'll get that all sorted out. I know a handful of us are junior astronomers, and I think I've seen most of you, but if you're worried that I'm not going to count you for junior astronomy, go ahead and message me as well, and I'll make sure that we get your cards punched and we can work towards that. With that, though, I'm going to say, take it away, Debbie.
All right. Well, let's get started, guys. I'm going to try to share the screen. I have a PowerPoint presentation. Hopefully it won't take real long, and I want to be sure to tell you, as Samantha did, that if you have any questions, feel free to interrupt. This is very informal, so it's not anything that I can't do. So let me see. Here it is. All righty. All righty. So. All right. Okay, so we're going to start. I'm going to close off my little thing here. Ugh. Okay, so this is anybody who's heard anything about the news lately or is on the internet has known that we just recently landed the Perseverance rover on Mars, and this is a culmination of a lot of stuff. So it's going to be, it made quite a bit of news in February when they landed, and it was and it's ongoing right now. I just updated it today that we've got, they actually, yeah, the rover roving today. It went a whole 23 feet, I think. It wasn't very much, but it's a start, and they're looking forward to bigger and better things, but we'll get on that. Okay, so this is what we're going to be talking a little bit about, and I'm not going to spend too long on the past idea about Mars and about the difficulties getting to Mars, but I think it would be nice to appreciate how hard it was for us to get onto and to get to Mars. And right now, what the present missions that we have on Mars are, and I'm going to spend a little bit more time on the Perseverance mission since that's the news, and I'm going to end with how you can see Mars. Hopefully tonight, if it's clear in your area, and if it's not clear, be sure to look out tomorrow or Sunday or any day within the next week or so where it's clear, and you'll be able to see Mars. Mars is actually the only planet you'll be able to see at night right now. Jupiter and Saturn will be coming up in the morning hours, but if you're like me, the morning hours just never are as good for looking at planets. And especially now that we're going to be jumping ahead with time, and it's going to be really, really kind of strange. Okay, so let's see. A brief history of Mars exploration. I got to see if I can close this. Okay. First of all, we've been fascinated with Mars for a long time. Mars has been in the human consciousness for, well, they say the Babylonians in 400 BC, but I'm sure anybody that's ever looked up, Mars has been like the moon. It's just been in our sky for so long that we've never not known about Mars. We didn't know what it was at first. They called it wandering stars, but this gives you just a real little brief history of what we thought. And it wasn't until the 1900s or 1877 when Chappelle, the Percival Lowell, was mapping the canals on Mars that they actually started thinking that Mars might be a place that we could actually visit someday, and that maybe even had a civilization, which of course our hopes were dashed about that. Anyway, our first missions to Mars were Mariner 3 and 4, and Mariner 3 was lost at launch. Mariner 4 did fly by Mars in July of 1965, which was before the moon landing, if you guys know when the moon landing was. It took a total of 21 pictures. That's what the toning on total means. But it kind of dashed our hopes that Mars was actually any kind of a place that we'd want to see or visit or have a civilization on. We took it to heart that this really wasn't what we thought. Percival Lowell, like I said, in the 1890s, mapped out this elaborate system of canals on Mars. So on the left-hand side here, you see what he thought he saw through his telescope. And this is an actual picture of Mars on the right-hand side. We thought there were all kinds of creatures living on Mars in Percival Lowell's day. We knew that it was smaller than Earth, so that we knew that any living organisms on Mars might be taller because they wouldn't have as much gravity to fight. And so they pictured this. They pictured this as a way of a Martian, and they said it would be colder. So this guy, I don't know if you could tell, has got a fur skin. John Carter of Mars books were real popular in the his first one was in 1918, and he wrote a series of 4 or 5 books all about the civilization on Mars. And again, it just brings to light the fact that we were very fanciful about Mars. And of course, then it shifts to, well, of course, if there's Martians, they must want to do us in. So the War of the Worlds in the 1930s came out, and it was a very scary picture of what these Martians might actually be after. So just a little brief history about what we thought of. This was the first picture that Mariner 4 sent. And again, remember, there are only 21 of them. The one on the left is really grainy, really not so good. See, if I can't even find my mouse. But anyway, the one on the left is grainy, and the other one looks grainy too. This was actually taken only 6,000 miles from the surface. This was a flyby mission. Oh, the one on the right is 6,000 miles above the surface. And it was a flyby, meaning that Mariner didn't go around Mars. It just literally flew by, kind of like the Voyagers did, and kind of like the Pluto mission way back in 2012, where it just kind of flew by and just took as many pictures as it was possible. In the 1965, it wasn't very many possible. But this was enough to convince people that Mars was not going to be a nice place to colonize, or we probably wouldn't have to worry about Martians. Because of the Mariner mission, we found out that we really don't have an atmosphere on Mars, or at least not enough of a one that would support any kind of life that we know. So a question that begs to be asked is, well, we've had a lot of missions to Mars. In fact, Mars has been the subject of a lot more missions than any other planet in our solar system, for multiple reasons, which I can get into if you're interested. But the missions to Mars, there's been over 49, 50 missions to Mars. And how many have been successful? Well, they said about half, and about half have failed. When they say fail, we need to kind of figure out what the word failure means. Does it mean they crashed? Does it mean they just lost communication? Does it Are we going to count flybys in a mission to Mars? It's maybe not a specific mission, but it did go by Mars. So it's really and when I say it's been about half, I'm talking about the ones that actually were planning on getting to Mars and sending back useful information. How many of them actually did succeed and sent back any information at all? There were a couple of Russian probes that actually went around Mars, and one of them even landed, but then they lost contact, or they failed, or something happened within just seconds of them landing. So they count that as a sort of successful, and you'll see what I mean when I go through it. And most of the reasons for the failures are just engineering problems or software errors. And sometimes, as in the case of the Russians, it was just totally bad luck. Just totally was bad luck. Like they landed and it was a...
SciShow Space is supported by Brilliant.org.
Let me stop for a second. I got to go back. When I say it, yeah, this is a real short video, and the guy does a much better job than I can explaining why it's so hard to get to Mars and what the problems of getting to Mars might be.
SciShow Space is supported by Brilliant.org. Thanks to its watery history and potential for past life, Mars has been fascinating people for decades. So it's no surprise that we've sent more spacecraft there than any other planet. We're talking 45 missions. Most other worlds have had just a small handful. The problem is, around half of the probes that have ever attempted to explore Mars have either crashed or disappeared. So as much as we want to understand the planet, getting to its surface is no easy feat. Mars's unique atmosphere often gets the better of us, and it's taken some creative engineering to get to the ground. Before Mars, the only places we'd ever landed spacecraft were the Moon and Earth. And while that did come with challenges, we had strategies nailed down pretty well for both. The hard thing about landing on Earth is that our thick atmosphere creates extreme friction and heat with incoming spacecraft. But we've solved that problem with heat shields. And besides, that thick atmosphere also means parachutes work very well. The Moon is kind of the opposite. It has virtually no atmosphere, which gets rid of the heat problem, but it also means parachutes don't work. We have to use retro rockets to land, little rockets that fire underneath the spacecraft to slow its descent. Mars, meanwhile, is a whole different beast. It comes with all the challenges of landing on Earth and the Moon, but with none of the real benefits. Its atmosphere is 100 times thinner than Earth's, meaning parachutes can't grab onto enough air to completely slow down the spacecraft. But unlike the Moon, there's also just enough atmosphere to create problems. Just like friction causes space rocks and old satellites to burn up in Earth's atmosphere, a space probe entering Mars's atmosphere can get hotter than 2,000 degrees Celsius. That's hot enough to melt iron and just about every other metal. So the millions of dollars worth of machinery we send to Mars needs serious protection to keep from being fried. So how do you get an expensive, heavy chunk of metal traveling tens of thousands of kilometers an hour to come gently to a stop on the surface of another world? A whole lot of creativity. And probably a good amount of coffee. Every mission to land on Mars starts with something called an aeroshell, a special capsule that protects its cargo against the heat. Its outer layer is filled with a material called an ablator that was invented in the 1970s for the first Mars landers, the Viking missions. It reacts with the Martian atmosphere in a way that removes the heat and leaves behind a trail of gas. It gets so hot that it glows red, but inside the capsule, cargo stays a little cooler than room temperature. Next, once friction has slowed things to about 1,600 kilometers per hour, a parachute opens, and part of the aeroshell is cast off. Amazingly, engineers are still using a parachute pretty similar to the one designed for the Viking landers more than 40 years ago. It's made of nylon and polyester, with tethers made of the same material as bulletproof vests. That makes it super strong and light, which is really important, considering the craft is still moving at supersonic speeds when it deploys. And while it isn't enough to slow down a spacecraft all the way, It does help. After a few minutes, the parachute brings the craft down to a few hundred kilometers per hour, and it gets discarded along with the rest of the aero show. Now, this is where things get really creative, and no type of mission has been exactly the same. Engineers have had to come up with special solutions to get each spacecraft on the ground. For example, those 1970s Viking landers used retro rockets like on the moon. But there was always the possibility that they'd botch a landing on uneven ground. And while they were fine for landers, carrying around a bunch of rockets would be a pointless burden on the rovers we started sending to Mars in the 90s. So for the Pathfinder mission that landed in 1997, which included the first experimental rover, engineers tried a new method: a cluster of airbags. After slamming into the ground, this robotic explorer bounced along for hundreds of meters. And by bounced, I mean it shot several stories into the air and moved as fast as cars on the freeway before rolling to a stop. But
I know, excuse me, guys, technical difficulty. There we go.
Okay.
Oh, shoot, I don't know if it's gonna, I don't know if it's gonna finish it. Oh dear. I think if I hit this now, it's gonna start all over, and I don't know if I could fast forward it. Let me see.
SciShow Space is supported by Brilliant.org.
Let me see if I can get it up to here.
In the future. And it's all thanks to some brilliant engineers and organizations. If you've ever dreamed of becoming an engineer...
Oh, good. So it was about over anyway. I'm sorry about that, guys. I've been having trouble with my stupid computer. But anyway, it's a really good little video, and it gave you a little bit of background on how they did it. And I'll talk a little bit more about how we got Perseverance and Curiosity and some of the other rovers on Mars. So first of all, and I always told my astronomy students this, that there's lots of different kinds of ways you could explore another planet. There's things called flybys, which the Mariner was an example of. There's orbiters. There's things like we have, Galileo was an orbiter around Jupiter for almost 10 years. And there's things that just do just that, they orbit. You could almost consider the International Space Station an orbiter around Earth, studying Earth. There's landers that just basically just land on Mars, and they're stationary. The Mars Science Laboratory or the Phoenix lander, I should say, is an example of that. And then there's rovers, the kinds with the wheels that actually go miles. And so this first thing, Voyager, is on the bottom corner here I showed, and that was a flyby mission in the 1970s that flew by Jupiter and Saturn, and actually Voyager 2 went past Uranus and Neptune also. The top picture here is a picture of the Viking orbiter. We don't often think of the Viking as having an orbiter. We know about the Viking landers, but there actually was an orbiter for each of the Viking landers. And the orbiter's job was, of course, for communication. Remember, this was in the 1970s, so it was a little bit harder. But I thought that was a really interesting picture, and it seems kind of dated now. It does almost look old-fashioned, doesn't it? This is the Viking lander. This is what we always picture with the Viking missions, is the lander that actually landed and that operated. And then, of course, these are our little fleet of rovers that we have now. We've had 5 rovers. There's only 4 pictured here, but that's because this middle one, the one that's above the summer of 2020, which is when Perseverance launched, it was actually called Mars 2020 until it was renamed Perseverance. But anyway, the one that says 2,000 pounds was the Curiosity rover, but the one that says 400 pounds next to it, to the left of it, that's one of the Mars Explorer rovers. You might have known them as Spirit and Opportunity. And the first little one that says only 25 pounds, that was the cute little, I don't know, boxcar called Pathfinder. Well, it was called Sojourner. It was part of the Pathfinder mission. But this is an example of flybys, orbiters, landers, and rovers. And this is the way we explore other worlds. This is just I just took a real quick screenshot of Wikipedia that listed all the Mars missions. And if you notice the dates in the third column, this is in the early 60s. And we didn't actually start having successes until 64 when Mariner 4, well, that's when it was launched. Mariner 4 actually flew by Mars in 65. But that was our first successful, it was the first any successful. And if you notice under type, right next to the color column, that's where it talks about flybys or landers. And we tried one orbiter, but that was, the Soviet Union failed to orbit. And so that was part of the failures. But notice it was a soft failure because it actually made it to Mars. So they don't cover as a dark of a pink. I thought that was kind of cute the way they did that. In the middle of the 80s and the start of the 90s, we still weren't doing such a good job. The United States had a little better record than the Soviet Union, but there were a lot of, you know, a lot of errors and a lot of, well, bad luck. One of the Russian ones, let's see, which one was it? It was the Mars 3. It did land, but it landed in the middle of a dust storm, and it only transmitted for 14 seconds before something blew it over or whatever happened to it. It died, but kind of sad, huh? But now look at, this is in the 1990s, well, this is in the 2000s. I jumped ahead, but now you could see that we have a lot of operational missions, and not that it's entirely successful. You notice the European Space Agency had a soft failure. It's a light pink. You know, it says that they had engineering data on the first 5 minutes, but then that was about it. So the ExoMars, but we have had some successful missions since then. And you should note that in the United States anyway, since 1999, the United States has not had any failures, which is kind of interesting. I guess we learned a lot in those first 30 years of trying to launch things there, but we had a lot better success rate. This is just a little graphic I thought very fascinating about how many things we've thrown at Mars. This includes a lot of countries, including Russia and Japan and the European Space Agency and stuff. Yeah. The Soviet Union, the old Soviet Union. So ESA is the Mars Express, but they have a picture of all our landers and, well, our rovers too. The Viking 1 and 2 in the Phoenix are just landers. They're stationary. They don't move, and neither of them are accurate. Neither of them are operational anymore, but they're still up there. How many things are actually still going around Mars? And according to Wikipedia, which I looked up, they said that there's 18 satellites still orbiting Mars. We haven't quite filled it up with space junk like we have here on Earth, but there are a lot of things orbiting Mars, and so that's something else that they're starting to have to take into consideration when they launch something at Mars. Is where are these things around Mars? I guess the probability of hitting something would be low, but it's not. It's minuscule. It's not zero. Only 8 things are actually operational right now. Like the Viking 1 and 2 orbiters aren't transmitting anymore. Neither is Mariner 9. I think all these other ones are, though. The Mars Reconnaissance Orbiter still gives us lots of valuable information. And a lot of the pictures they take are from the Mars Reconnaissance Orbiter, and they show pictures of where we've landed and what things look like from Martian orbits. This is a little bit, oh, what did I do this one for? I don't know why I did this one. I had some reason. Oh, this is up to date now. This is in July of 2020. These were launched. Notice it has the United Arab Emirates, and it has the Chinese mission to Mars. These were launched in July of 2020 when we also launched Perseverance. Perseverance, I must have cut off the screenshot on it, but we had, for the first time, launched 3 missions to Mars in one launch window. Mars has a 3-week period every 26 months in which you can launch something and hopefully get it to Mars. Let me say that again. It's only a 3-week window, and it only happens every 26 months. So in July of 2020 to, I think, the first week in August, there was the start of this 3-week window, and we had 3 missions from Earth by the United Emirates and the Chinese and our own Perseverance that launched within that window. And all 3 of them have made it to Mars. So it's like, yay, there's a lot of good stuff going on. And that would be interesting to see. Okay, this is where they've landed and future landings, because the one that's kind of underneath Viking 2 and above Perseverance, the Tianwen, and I'm sure I'm not saying that right, but the Tianwen, that's the Chinese one that launched last July. And they plan on sending a lander and a rover down, but they are right now just orbiting Mars. So it's a 3-for-1. It's going to have the orbiter right now, and by May or June, and the Chinese haven't exactly said when, they're going to send a lander down, and attached to the lander will be a small rover. And that's where it's planning on landing. So it's going to be landing kind of, well, it's not really close to Perseverance, but it's not really on the other side. Something you should notice is how when we launch 2 things at a time, like Viking 1 and 2, notice how they're on opposite sides of Mars. And this is a Mercator projection of Mars. This is the whole surface of Mars. You'd have to imagine it being wrapped around in a cylinder to visualize a globe. The Viking 1 and 2 are on opposite ends of Mars, as were Spirit and Opportunity. Those were our twin rovers. Perseverance is not so much, and we chose its landing site just based on the crater that we found so interesting. Phoenix, the lander that's kind of way up at the top, that was specifically designed to study the northern pole of Mars. So that's why it's so high up. It's actually above the, well, you wouldn't call it Arctic Circle, but if Mars had an Arctic Circle, it'd be above Arctic Circle on Mars. And so this is, anyway, again, the only future one is the Tianwen. Everything else is already landed or is already on Mars. Okay, I'm just going to real briefly go through what we did do. And this is just little past successful missions. The Viking 1 and 2 in 75, which both landed. They both landed in 76, and they weren't really very active for very long, but it gave us our first really close-up, nice quality pictures. You remember that grainy picture I showed you of Mariner 4? And while we had better pictures since then, the Viking was the first mission that actually gave us this detailed. You could see the rocks on the surface of Mars there. You could see the boulder field that it seemed to have landed in. And remember, as that guy was talking about in the little short video, there was always the worry that they would land, one of the legs of the lander would be stuck on a rock and it would be tilted off sides or crazy at an angle or something. It was, you know, because these things had to land on their own. They weren't able to be directed down. They had to kind of land on their own. So, and there was the orbiter, of course. Remember, the Vikings did have orbiters, mostly for communication. Sojourner was our first little rover. It's such a cute little thing. It's only, I think it said 25 inches, a little over 25 inches. So, you know, it's really, really small. If you look at it, would fit definitely on your tabletop. Even if you have a small card table, it would fit on your tabletop. It was only 23 pounds. And for 85 days, it didn't wander around. It only traveled 100 meters, which is like a little bit more than a football field, but it didn't really do, it did send back signals, and it was what they call a proof of concept. They were trying to see if they could actually send something that could robotically rove or move on the surface of something besides the moon. Well, on the moon, we had rovers, but remember, they were driven by our astronauts on the moon. So this was a remotely controlled rover on another planet. So it was kind of like the forerunner of really good things to come. Anyway, it was low cost. And when you start comparing it to the billions of dollars we've spent since, 150 million for the lander and 25 million for the rover was really a bargain. And so it was possible to do something really cheaply, but again, the science was very limited that they did. It was more of a proof of concept that they could do it. The Mars exploration rovers were just wildly successful. they'll shine forever as our glory moments, where they were designed for something like 90 days. And they figured that after 90 days, they would be covered with dust so much that the solar panels that powered them would be inoperable, because they needed at least, I think I read, 100 watts of power to operate. And they figured that they'd be down to only 50 watts after 90 days. But what they found out is that they were getting even more power than they expected. And it was because of Martian winds. Martian winds would actually clear the solar panels, and the solar panels operated for, well, you could see Spirit was active for 6 years, and it wasn't the solar panels that did it, and it was its wheels. Its wheels got stuck in the Martian soft sands. But 8 more years, Opportunity was going strong, and finally it started running out of power. But these guys landed in 2004, so 14 years is kind of a heck of a long run for something that was only designed, or they only thought would work, for less than 3 months. And it was the first to characterize Martian rocks and look for past clues for water and stuff. So again, I can't sing enough praises for the Martian rovers, Spirit and Opportunity. They were amazing things. Again, though, they were only solar powered. And Mars doesn't get as much sun as the Earth because it's a little bit farther out from the sun. But it was able to operate just fine. The Curiosity rover is a little bit different. One thing you may notice is that there are no solar panels. The Curiosity rover, and as the Perseverance rover, has what they call the radioisotope thermal generator. So it's basically nuclear powered, and it doesn't have to rely on solar power. All that meant that it weighed a lot more, and I have a slide coming up that'll talk about the weights and stuff, but that made a big difference in how they were going to get them to Mars. And so the Curiosity rover has been operating since 2012, which means it's been over 3,000 Mars days. It's not traveled a whole lot. It tends to rove and stay in one place. They said out of the 3,000 days that it's been roving, only like, I think they said 80 are actually days that they've actually moved it. So it mostly stays in one spot and does its thing. And its thing is all those attachments that it has, all those different scientific instruments. One thing you should know about the Curiosity rover is that it cost a lot to produce, but they used pretty much the exact same design for the Perseverance rover. I'll have another slide and you'll be able to see the comparison. There's very few modifications that they made on the Perseverance rover, other than the fact that they updated and they added a different suite of instruments, scientific instruments. But the basic body design and actually the deployment and the landing design was just like the Curiosity rover. So the Curiosity rover broke some ground, and it did this. It was the first one that landed with that 7 minutes of terror thing, which we'll talk about in a little bit. You should know that it was the first one, and its mission, like Perseverance mission, was to see if it had any past life on Mars. And actually, NASA does a strange thing when they talk about mission objectives. They said they were going to see if they could find organic molecules, or if they could find conditions that might have supported microbial life. And that was Curiosity's mission, where Perseverance's mission, the present one, is that they are actually going to look for evidence of that past microbial life. They're pretty sure that they'll find it eventually, but they, as Carl Sagan said, extraordinary claims require extraordinary evidence. So they're looking for that extraordinary evidence. This is history of a little bit of rovers. They even include the lunar ones. The red ones here are the ones on Mars. And you could see the Curiosity rover hasn't gone very far. Opportunity really did, well, in 2015, before it shut down, it already had over 26 miles. And this was the landing system for the Mars Explorer rovers, that Mars Exploration rovers, Spirit and Opportunity. Spirit didn't get as far, but remember, Spirit kind of pooped out a little bit sooner than Opportunity. Opportunity went another 8 years after Spirit. So Opportunity's got the high standard here, and I'm not sure what they expect and what they plan on doing for Perseverance, the present rover up there, but it got off to the start today, or 2 days ago, I guess they said, or yesterday. They said that it actually went its 23 feet. And actually, yeah, I'll get to that later. Okay. Okay, fun facts about the rovers. This is the one I wanted to show you. Sojourner, the very first one, the really small guy that was only 23 pounds, it only had 3 cameras. But remember, it was only 25 pounds too, so it was really pretty lightweight, very small. A kid could have carried it around relatively easily. Spirit and Opportunity, the next Mars exploration rovers, they actually didn't have, well, they had 3 times as many cameras, but they only had 9 cameras. And remember, this is the early 2000s, and they were only our second and third rovers that we had sent off to another world. So, and they actually did it in double because they were hoping that at least one of them would survive. You remember the 50% failure rate, you know, even though we were very happy that they both survived, there wasn't a guarantee of that. And notice the memory thing, 256 megabytes of flash memory, which is, if you know anything about computers and memory, you know that that's not very much anymore. But then we come up to Curiosity, and you can see that we increased the cameras again, almost doubling them. We've got gigabytes of flash memory. And of course, we have a lot faster processing. And we can send it because we have the Mars Reconnaissance Orbiter, and we have other orbiters that we relay our information from our rovers on the ground up to the orbiters that are orbiting Mars before they get sent to Earth. And then the Perseverance, you could see, this picture makes it look like Perseverance is much bigger than the Curiosity, but it really isn't. But it does have more cameras. It does weigh a little over 300 pounds more than Curiosity. So it was definitely a step up, and they definitely did a little bit upgrade on the information. And this, I really like this picture because all those other pictures, you don't have a sense of how big these guys are, but this one kind of shows it to you. You know, the front one in the front at the guy's feet next to the red rock is, of course, Sojourner, the 25 pound, 23 pound, 25 inch long rover. And the Mars Exploration Rover, there's only one of them. It's a mock-up of either Spirit or Opportunity, or probably they were a twin identical. So it was a mock-up of that. And you could see it was bigger. But then, of course, the Curiosity and Perseverance are like the one on the right, although that's a model of the Curiosity one. It's more like a small car. And I think you get a sense of that when you could see the guys and compare it to their size. So this is a comparison of the tires. Look at Sojourner, it looks like a little toy, doesn't it? So funny. Spirit and Opportunity and Curiosity's wheel tread. They changed the wheel tread a little bit on Perseverance, but they compare it to a car tire on the far right. And you could see that it's still smaller than a car tire, although it's a lot wider. And of course, that's because they're trying to keep it from sinking in the sand, which they had problems with Spirit and Opportunity. I don't know what the banana is for. I'll let you guys use your imagination, but maybe it's just to compare how wide it is. It's like a banana. I don't know. Sometimes my bananas are big. I don't know. Okay, getting into the new orbiters. And this is the Emirates, the United Arab Emirates Space Agency sent this. Again, they launched in July, like all of the missions. They did go into orbit. They were the first one to go into orbit. They went into orbit February 9th. And at the time of its launch in July, it was only given a 50% chance of success. So it's the very first mission the Emirates have sent out into space. So the fact that it was successful is, you know, kudos to them. They did a great job. But it's just going to be an orbiter. It's not going to have a lander. It's not going to have a rover. It's just in orbit around Mars. And it's hoping, of course, to just study the weather and the dust storms and whatever it can from space. It was more of a proof of concept that they could do it, and so they're hoping that they can do more things with it. It's in a really strange orbit. If you ever get a chance, it's very elliptical, where it gets really, it doesn't get real close to Mars, but it goes really far out. When I say ellipse, I mean it's not circular orbit, which a lot of things are a little bit more circular, and it's not quite as much. It is pretty heavy. It's 3,300 pounds, which is kind of a lot, but it is orbiting successfully around Mars, and I haven't read anything about it returning any data yet. So I'm not sure if that's still because they're checking out the instruments or whatever, but it's been almost a month up there. So I'm hoping we could start hearing some stuff with what they're doing and what they're getting. It was, there were some American universities, including the University of Arizona and Colorado, that actually did some work on helping the Emirates get this mission launched. But it was the Arabs that actually did the engineering, so that was good. Oh, there's the little thing. And this was this was one of its first pictures from orbit, and it was taken the second day. Now, if you compare that to the picture that I showed you of Mariner 4 at the beginning, where you couldn't even see that was really something, this is a very clear picture, and the Arabs were very excited about it because up here at the top, you could see the atmosphere of Mars, a really thin atmosphere, but you could actually see part of it. And of course, these are the 3 volcanoes. This is the Valley Marineris. This is Olympus Mons over here. It's, very clear, very crisp picture, and so they were very excited that they got such a nice picture, and yeah, they did a good job. Now, the Chinese one, it's a lot harder to find information on them. And I'm not sure if it's because the Chinese just don't like sharing or if they're just not talking yet. But this is what they have in orbit right now. They have this whole contraption that's over here. And it is China's first independent Mars probe. China did team up with the European Space Agency a few years back and tried unsuccessfully to get something launched by the Europeans. And that was one of the failures. But this is one of the heaviest things ever sent to Mars. It weighs 5 tons at present. Remember, the Arabs are like 3,300 pounds. 5 tons is like 10,000. Yeah, 10,000 pounds, right? It entered Mars orbit a day after the Emirates, and it's planning on sending down a lander with an attached rover in May or June. So it's kind of like stand by and see what happens. But it's all hidden inside the orbiter for right now. And I have not, in fact, I had a hard time finding pictures of this on the internet. It's like the Chinese really are not sharing a whole lot of information. But that's just maybe my take, and maybe I'm just not as good at Google as some other people. This is a picture of what they think it looks like from orbit. And I'm not sure how they got this picture, but I think it's kind of cool that they have the solar panels deployed and they have the dish. It almost looks like part of the dish is missing, but that's, I don't know. Again, I don't really know much about this one. I had a hard time finding. If you look it up on Wikipedia, it's very small, very little information. And that's, the name Tianwen means heavenly questions. So they give it a cool name, and that's the little Chinese symbol for it. This was their first picture that they sent back. This was actually taken before it went into orbit, and the Chinese released it about a week later. They don't do anything right away. But anyway, they released this picture about a week later, and it's about 2 million kilometers, or about 1.5 million miles from Mars. This is as it was approaching the orbit to orbit Mars. And again, remember, a lot of missions at this critical point don't fire the retro rockets or don't get into orbit. So the very fact that they, on their very first shot, the Arabs and the Chinese both got their orbiters to get into a Martian orbit that was stable is very much an accomplishment. So they should get some kudos for that. And it entered orbit the day after the Arabs, but it was not a contest to get there first. That was never the image. And I want you to compare it again to the Mariner 4 orbital pictures. Not very good at all, those 1965 pictures, right? But then again, remember, TV was new. Remember how grainy if you've ever seen the moon landing pictures, those were pretty grainy too. So I guess it's good that we had any pictures. Now we're getting up to the Perseverance rover, and this had a very, very unique landing system, which was pioneered by the Curiosity rover. So it goes through the 7 minutes of terror, and the 7 minutes starts when it hits the atmosphere before the parachute deploys. But it hits the atmosphere going over 12,000 miles an hour. I mean, it hits fast, and it does. You could see the heat shield glowing in the third image if you're going from the left. If you see the third image down, you could see the heat shield glowing, and then they deploy the parachute, which is a really unique thing. They spent a lot of time developing a parachute that would work in the thin Martian atmosphere. They had to judge size versus weight. They wanted to make something that was very lightweight because there isn't much atmosphere up there to catch a parachute and to open it, but there's enough of an atmosphere that there would be something. And so the parachute was very critical to slowing it down to a reasonable speed. And if you notice at the bottom of each of these illustrations, it tells you about how fast it's going. So by the time it gets to the guided entry, it's still going over 900 miles per hour. But by the time it has the heat shield separation, it's down to 360. So it really does do its job of slowing things down. By the time the parachute is ejected, right here, the third from the bottom, and I'm not sure why I can't get my cursor, but anyway, the third from the bottom, you can see the back shell separation. It's going about 200 miles an hour, and it's only at an altitude of 13 miles. But then it does what they call the powered descent, and that's where it fires the retro rockets. So it's both parachute and retro rockets that it does, and then they deploy the sky crane, which is amazing. So that by the time the lander actually lands, it's going a little over a mile per hour, which anybody could walk that fast. Even I can walk that fast. Anyway, and then of course the powered descent stage flies away. This is a little very short video on the landing, but it's really kind of cool. You really should.
We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Indicate chute deploy.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 480 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Now these are actual pictures.
To subsonic speeds, and the heat shield
The
has been
swaying that
separated.
you're seeing is
This
actually
allows
the lander
both the radar and the
swaying.
cameras to get their first look
on
at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
"90 meters per second is about 200 miles an hour. So it was going a little bit faster than that. But the swaying and the movement that you're seeing is, remember, this thing is taking a picture.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface.
It's swaying. No.
Perseverance is continuing to descend on the parachute.
And that's why it's rocking, because it's actually
the
swinging.
initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
OBS valid.
We have confirmation that the lander vision system has produced a valid solution and part of.
I'm going to pause it there just for a real quick explanation. This was the first time that NASA was able to give us a front row seat to what the 7 minutes of terror looks like. These were actual pictures taken from cameras that were mounted on the underside of the rover. So these are actual pictures as it's entering Mars, after it lost its heat shield and it was deployed with the parachute. These were actual pictures taken from the rover. So you really have a front row seat with this. And when they're saying a valid solution, they're saying that this rover had it wasn't the rover at that point, it was the whole configuration, the whole Perseverance had a chance to do what they called smart navigation. If they saw strange rocks or something strange on the surface for the landing site, it was able to make instantaneous decisions about where or shifting its landing site. It was able to do that, and that was a new technology that they employed to make it a safer landing. And I'm not sure if it had to do any maneuvering, but because I think they got it spot on. But again, you're seeing your front row seat here. You might be hanging off the bottom of the rover right here.
Terrain altered navigation.
Grimy. PPA is nominal.
We have
There's the
timing
crater.
of the landing engines.
That's the crater that they're aiming for, kind of like right in the sights, and then it's going over.
Shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated.
Which means
We
the
are currently
parachute is
performing
gone.
the divert maneuver. Current velocity is about 75 meters per second at an altitude of about 1 kilometer off the surface of Mars.
Tianwen, safety Bravo.
You're going to see the retro rockets fire
We have
soon, and you'll see
completed
some
our
dust
terrain
being
altered
kicked up.
navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of
You'll
Mars.
start seeing the sand
Started our
actually being.
constant velocity
Look at that.
accordion,
That's
which means
from
we
the
are
from
conducting
the
sky crane,
thrusters.
about to conduct the sky crane maneuver.
And on the left side, they're showing other pictures that the rover was taking.
Sky
Look,
crane
there's
maneuver has started,
there's it being dropped down on its
about
tether.
20 meters off the surface.
And notice the surface underneath it is all, you can't see anything because the retro rockets are still firing at this
We're
point.
getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely
And
on the
there it
surface
is,
of
it's
Mars,
landed.
ready to begin seeking the sands of past life.
Yep, and they finally got it. Remember, all this happens without any human control at all. This has got to all be done remotely because of the lag time. Jezero Crater is where they landed. This is a past picture and artist concept of what it might have looked like 3 million years ago, or 3 billion, well, yeah, 3 billion years ago, I should say. They think the lake itself might have lasted 1 to 10 million years. And the reason they liked it so much is because they had evidence of the deltas and stuff, this in and out business. At the very top, you could see an inlet of water coming into the lake, and then at the bottom right, you could see some water leaving it. And, so that meant that the lake has a lot of sediment at the bottom. And of course, that's where Perseverance landed. It landed at the bottom of this ancient lake bed. And of course, the Mars Reconnaissance Orbiter was able to identify that there's certain clays there. And evolutionary wise, they think that clays might be a really good spot to look for evidence of past life. Jezero means lake, by the way, in several Slavic languages. Just thought I'd share that with you guys. And this was another really quick thing about what this crater looks like.
John, we had to choose a specific place on Mars to land. Can you tell us where we're going to land and how we chose that spot?
The science community really came up with about 30 different candidate landing sites. And we focused in on and selected the Jezero Crater landing site because it's a place where there used to be a lake. And as important as that, there's also on the western side of the crater a place where a river flowed into that lake and deposited a large delta. And it's those sediments in the delta and in that ancient lake that in parts are underneath that delta that really focus our attention on where to go look for biosignatures and possible evidence of past life.
Okay, John, the big question is, are we going to find life this time on Mars?
The Perseverance mission, really, the landing site selection, the instruments on the rover, have all been selected to try to answer that question once and for all. We don't want an answer that we don't have confidence in. So we really kind of pick the place on Mars where we think that if there's evidence of past life, it ought to be preserved there. And so by going to Jezero Crater, we really hope that we're going to have a yes or no answer about whether or not there was ever life on Mars. We won't be left scratching our heads and wondering.
But you're telling me that we probably won't find any little green men?
No little green men. We would have seen evidence about that long ago.
One thing that I thought was kind of fun is that the NASA engineers have a good sense of humor. And as you know, this whole last year, they were working from home. They came up with, let's hide a message in some of these things. So there's a hidden message in this parachute. You have to know binary code. And if you know the binary code, there it is. It actually spells out dare mighty things. And it gives the GPS coordinates for the Jet Propulsion Laboratory in Pasadena, California. But anyway, they had to color the parachute something, and so they just decided to make it something that would actually have a message. There was an ulterior motive too. They were trying to figure out the orientation of the parachute, whether it was twisting around or whatever, and how it would open. But I thought it was kind of cool that they did it. There's another little hidden message in the Rover tires. And that's in Morse code, if anybody knows Morse code. And it's on the left side here, it goes JPL. And it goes with the series of dots and dashes. Thought those clever little NASA engineers. There's supposed to be a third hidden message, but you're going to have to wait until the robotic arm takes an image of the underside of the rover. There's one last hidden message. So it's kind of like stay tuned because they haven't taken that image yet. I thought that was kind of cute. So this is a little graphic of the different instruments that they have. A lot more upgrade than the Curiosity rover, which is still active. And they're hoping to get a lot more things. I think one of the more fascinating ones is this MOXIE at the very bottom, where they're actually going to try to generate oxygen from the carbon dioxide atmosphere of Mars, which would be a real big step if they could see if they could do that, because that would definitely have good news for any future human missions to Mars if we can actually generate oxygen from the Mars carbon dioxide. Okay, so what's new and improved? Well, Perseverance borrowed from Curiosity's body style. I think I mentioned that Perseverance costs less than Curiosity. It costs less because it actually used parts that they didn't use on Curiosity. If they had an extra wheel, they just transferred it to Perseverance. They just didn't make another one. You know, they and I'm being facetious there, but it was sort of like that. They used the same basic body style, so they had the design done, which of course in engineering terms, that takes a lot of time. So that's why it cost a little bit less. And let's see, I think this was going to be a movie, but I don't think I'm going to show it. Yeah, this is a picture of Curiosity and Perseverance, and you could see it, they almost look identical, and then they compare it to a Tesla. If you look at the length, width, and height, Curiosity and Perseverance are identical. Perseverance weighs a little bit more, but that's because of the instrumentation, and I'm not sure how it compares with the Tesla model, but as far as weight, but it's a pretty small vehicle. The tires are a little bit different, the wheel tread, and the biggest thing is that Perseverance carries a little helicopter. The helicopter isn't really got any scientific mission behind it. It's just going to see if it could fly. It's kind of hard to fly in the Mars atmosphere because, again, the Mars atmosphere is so much thinner. And I'll show you, this is a little picture of it's only a minute long. It just shows the helicopter is actually underneath, attached to the belly of the Perseverance rover. So there's Perseverance rover, and the camera is aiming at it. They're going to take a picture of it flying off. This won't be deployed for about a month yet. So it's not something that we're going to hear about right away. And they planned 5 flights. And again, there's the only scientific part of this flight is to see if it could be done. They really don't know how it's going to work. It only weighs, wow, what does it weigh? Shoot. I want to say it only weighs like 4 pounds. Yes, it's only a 4-pound helicopter. So it's not a very big thing at all. Oh, and my last slide, or my second to last slide, is where you can see Mars. And if you notice, there's Taurus, which is the bull in the sky. So Mars is in the constellation of Taurus. And yesterday, it was as close to the Pleiades as it's ever going to get, or not yesterday, 2 days ago, I guess, on Wednesday. But it will be right around the Pleiades for the next several days. So if you're out and you can see Taurus, you should be able to find the Pleiades. And if you can find the Pleiades, you should be able to see Mars. Now, don't be confused, because where it says Taurus, where it says Aldebaran is also a reddish star. So you'll be seeing 2 red things. Mars should be just a little bit brighter than Aldebaran. And this is a little sky wheel. This might be a little bit easier to see. Here's Aldebaran, and here's Mars. And then if you go this way, you should see Betelgeuse. So if you look at the belt of Orion, and last night I was able to see the belt of Orion, part of Orion points up to Aldebaran. And then if you continue on, you should be able to see Mars. And if you go the other way with Orion's belt, it points down to Sirius, which is one of the brightest stars. It is the brightest star in the Northern Hemisphere. So it's only 11 light years away. That could have something to do with it, but Sirius is one of our brightest stars. So again, find Orion's belt, which most people can do, go up towards Aldebaran and go a little bit past that first reddish thing you bump into, and you should see Mars. It's not going to be very bright. Mars is getting farther and farther from us, but it is out for a few hours. And if it's clear out tonight, you should go check it out. I want to put a little plug in for this thing called skymaps.com. You can download these every month, and it gives you a picture of the night sky for the whole month. This says early March at 9 p.m. and late March about 8 p.m., which with time change, it'll probably be about the same thing. So you could see that Mars is actually going to be out for quite a while. It's not like it's going to be setting in a few hours. It should be out right now if you can see it. So that should be fun. And lastly, I just threw this in at the end. I like these first color panorama shots. And again, look at the difference in the landings. This was in August 12th. The top one was Curiosity's first 360-degree panorama in Jezero Crater, and it pictures Mount Sharp right in the middle. The Jezero Crater at the bottom is where Curiosity is right now, and it's kind of got a little self-portrait in there, which is why it's so distorted. But you can see the difference in landing sites. And the Jezero Crater is definitely a little bit rockier, I would say, or a little bit more whatever. One of the features that they're looking at is this little layering right here in the middle. I wish I could show it's a little bit, can't get my mouse, but anyway, it's right above you can see the little layers in the crater walls there, which is really interesting. So are there any questions or anything that I haven't covered that you're burning desiring to ask? Otherwise, I'm pretty much done with my presentation.
I have a quick question. Did they make any improvements in like the speed that they can travel, or do they keep them slow so they're cautious?
Yes,
about not hitting things.
Right. If they go 100 meters a day, that is like rocket speed for them. And remember, that's like a football field only, so it's not very much at all. It's because remember, once they send a command to move, the rover is really on its own. If it runs into something that they can't see or anticipate, it's got to make a decision about go or no go on its own, because they say there's an 11-minute lag time between, and it's growing more as Mars gets farther and farther from Earth, between the time that they send the command and the time that they actually get an acknowledgement. Yeah, so it's definitely a challenge. It has to be autonomous, so they don't go fast. They're not even worried about speed.
Well, I was wondering on how much smart technology it might have. I mean, I know they equip that with Roombas now where, they can sense obstacles and make adjustments. And so I was assuming perhaps they would do the
yes,
same.
they definitely do, but that hasn't increased the speed. As far as I understand, that hasn't increased the speed that they want to travel at, because it's never been a contest for speed. Look, it took what, 11 years for it to go 23 miles, and that was Opportunity, 26 miles, and that's got the record. So that's pretty long marathon. 11 years and 9 months, almost 12 years. It's crazy. No, I don't think they're going to do. And what I read yesterday that they just did with Perseverance is they went forward. Let me see, what did I see here? Get it right. They went forward like 12 feet, and then they went back. They did a 150-degree turn, which is not quite turning around, but they did a 150-degree turn, and they went backwards for 8 feet. And so the 8 plus the 11 came up to the 23, or I don't know, I guess I didn't do the math right. But anyway, they only went 23 feet yesterday, but they at least got the idea that the rover can move. And small success.
How long do they think this mission is going to last?
They always give it a lifetime of less than what they think. When they did Curiosity, they said that Curiosity was going to go for 2 years, but at the end of 2 years, they said we'll go indefinitely. The RTG, the radioisotope thermal emission, thermoelectric generator, is good for 14 years. So I think that would probably be the limit, because it has no backup as far as solar panels or anything. That is its only power source, is that thermoelectric generator, the radioisotope generator. So 14 years would be the most, but I think they cautiously say 2 years, and that way when they pass it, they're all excited to go, look, we lasted longer. Got it going.
I have one other quick question, and I won't ask any others, but you had talked about how there was such a narrow window of time to launch. I think you had said something about 3 weeks and every 26 months. Is that?
That's right.
Correct? So did they already have a future launch for another something planned?
They do not. They do know that if they had made it to August 10th, I can't remember the exact date, but if they had made it to August 10th and for some reason Perseverance hadn't launched, it wouldn't have launched until September of 2022. That's the next opening window. And as far as I know, there's nothing being planned unless the Chinese got something else in the wings, because they don't really advertise too much. But September of 2022 is the next launch window. And then it takes like 6-7 months to get to Mars. But they have to have those launch windows, and they are very narrow windows, because hurricanes, weather, tornadoes, I mean, Cape Canaveral, and it's still got all that kind of stuff. There's all kinds of things, not even counting the stuff that could go wrong with putting it in the vehicle. It's an incredibly complex operation. I'm glad I don't be in charge of it. Yeah, oh, there we go. Oh, hi, look at that. I could see some people. Well, it's always fun, guys. I appreciate you all showing up, and it's always fun. I think you should try to go outside and see if you could find Orion, and if you could find Orion, use what I told you. Go upwards or to the right, see if you can find Aldebaran and the Pleiades, and then you can go down. If you go down and to the left, you should be able to see the bright star Sirius. I was able to see it. Hopefully you would. That was yesterday. I don't know. It looks kind of cloudy for here. But maybe somebody out there has got a better sky than me. Hi, Bonnie. Well, they say that that generation is going to be the one that's going to actually get people on Mars. I was reading that Elon Musk wants to send real people. He wants to start a colony by 2050. They keep on pushing that date. First it was 2030 and now it's up to 2050. So I don't know if they'll ever get people on Mars, but I think we're doing a good job just with robots right now and rovers. So we'll
Great presentation. Really interesting. Thanks.
Oh, thank you, Laura.
Yeah. Yeah, really good.
Huge fan. Thank you.
Well, I'm glad you enjoyed it.
And thank you so much, Debbie, for presenting again. You are like the heart and soul of the Nature Center astronomy.
Oh,
so thank you.
I really do enjoy astronomy, and hopefully we'll be able to do something on the sun, because that Parker Solar Probe has been returning really good stuff lately. We'll find out some new stuff about the sun. So I don't know. I'm already thinking about the fall and what I want to do first.
Well, let me know, and I will schedule you as much as you want to do. So.
Well, thank you very much.
You bet.
Well, thank you all for coming. I really appreciate your support, and I hope you learned something. And since this is being recorded, if anybody needs to get a hold of me, they probably can get a hold of me through Samantha, who's got an email address and stuff. And I certainly wouldn't mind answering any questions.
Just put it in the chat box. It's naturalist@ernc.org.
Yeah, so if you think of something later, she could forward it to me. That's a much easier email address than mine.
All right.
Thanks.
Okay, bye. Bye.
Thanks, Debbie.
Thank you, guys.
Thanks again. Bye.
That was real.